Hello, we are going to start the first module of electric drives and control for automation. First module, we are going to see the DC machines and its principle of operation and mainly DC generator. This is the broad classification of electrical machines. Electrical machines are broadly classified into DC machines and AC machines. DC machines are direct current machines. AC machines are alternating current machines. You know the difference between the AC and DC. AC is the alternating current, that its direction changes time to time. That means it is having both positive cycle and negative cycle. DC machines are direct current machine, that is a steady value of current is there. It is having same polarity, either it is positive or negative. It can't alter its polarity. Okay. Then DC machines are further classified into DC generator and DC motor. DC generator, we know generator is mechanical to electrical energy converter. The output of the generator is electrical energy. It is in the form of DC, so it is called DC generator. Motor is electrical to mechanical energy converter. The input of the motor is electrical energy. The input of the motor, if the input of the motor is DC, that is called DC motor. AC machines are further classified into synchronous machine and asynchronous machine. Synchronous machines are machines having constant speed. That speed is called synchronous speed. Okay, its speed can't vary. That synchronous machines are classified into synchronous generator and synchronous motor. That is also single phase and three phase. Asynchronous machines are induction machines. That's also available in single phase and three phase variants. This AC machines, we are going to study the synchronous and asynchronous machines in our 4th and 5th module. First module we are going to study DC generator. Second module we are going to study DC motor, and third module we are going to study about transformers. Like that. Then AC machines are there. Last module, the controllers for automation. So this is the classification of DC machines, DC generator and DC motor. This is what is DC generator and what is DC motor. Next we are going to see the construction of DC machine. The construction of generator and motor are similar. Electrical machines are basically depends on Faraday's laws of electromagnetic induction. First year you have already studied about Faraday's law. That means Faraday's first law and Faraday's second law. Faraday's first law is whenever a conductor cuts a magnetic flux, an EMF will be induced. And the Faraday's second law, that is the value. That means EMF induced is proportional to rate of change of flux linkages. So according to Faraday's law, whenever a conductor cuts a magnetic flux, an EMF is induced. So in order to generate an EMF, a conductor should be there, magnetic field also should be there, and conductors should cut the magnetic flux. So there should be a magnetic field should be there and a conductor should be there. So construction of DC machine. A DC machine consists of mainly two parts: a field system, then a conductor. Okay, field system and conductor. This conductor should cut the magnetic flux produced by the field system. So here in DC machines, the field system is the stationary part in that the conductor rotates. Okay, so mainly two parts are there, a stator, that is a stationary part, and a rotor, that is a rotating part. In the case of DC machine, the stationary part is the field system, the magnetic field, and the rotating part is the conductor. Here there is a conductor assembly is there, not only a single conductor, a conductor assembly is there, that the assembly of the conductor, and this part is called armature. So main parts of a DC machine are field system and armature. See here, this is a cross-sectional view of a DC machine. It has different parts: frame or yoke, field winding, shaft, pole shoe, field pole, commutator, armature conductors. This is the 3D view. Okay, we will see what all are these parts and what are the purposes. Okay, these are the various parts of a DC machine: yoke or magnetic frame, field system, armature, commutator, brushes and bearings, shaft, air gap. First part is yoke. Yoke is nothing but that is a magnetic frame. The outer covering of this DC machine is called yoke. Okay. The function of the yoke is it provides a mechanical support for the poles, that is the magnetic poles, okay, and acts as a protecting cover for the whole machine. It carries a magnetic flux produced by the poles. In small generator, the yokes are made up of cast iron, and for large rated generator, cast steel or rolled steel is employed. Yoke is nothing but the outer cover of the DC machine. In this yoke, we are fixing the magnetic poles. Okay. Next, the field system. That is a magnetic field system. Already we have seen this field system is a stationary part of a DC machine, and the field system consists of pole core. This is a pole core, and then pole shoes and pole core. Here we are having the field winding. Okay, actually the function of the field winding is to provide the magnetization. Normally in the DC machine we are using electromagnets. Electromagnet means that will magnetize only when electrical energy is supplied. That electrical energy is given through this field winding. Okay, field winding is wound on this pole core, and here one shoe shaped structure is, you can see here, one that is not a regular rectangular structure. Here some shoe shaped structure is there. The function of that is called pole shoes. The function of the pole shoes, that is the main two functions are there. They spread out the flux in the air gap, and also being larger cross section, it reduces the reluctance of the magnetic path. The main function of the field system is to provide the magnetic flux. In that magnetic flux, our conductor rotates, that is our conductor is armature rotates. Armature, that rotation of the armature will cut the magnetic flux and produce the EMF. So here main function is to produce the field system is to produce the flux. This air gap, that means this pole shoe, this structure helps to concentrate the flux into the air gap, and it is having larger cross sectional area. The area increases, we know, resistance decreases. The magnetic resistance is called reluctance. Reluctance decreases, so more flux can be flowed through that. And also this shape that supports the field winding. We know the field windings are wound on this pole core. This structure supports the field winding. The field windings are made up of copper wire, and are placed on the pole core. When current is passed through the field coils, they electromagnetize the poles, which produces a necessary flux in that is cut by the revolving armature conductors. That already we have seen. Next is the armature. This is armature core. Okay, armature. Armature is a rotating part and it consists of armature core and armature winding. Armature core houses the armature conductors. See here, this is the armature. It is having slots on its outer periphery. You can see the slots here. In that slots, we are placing the armature conductors. That conductors cut the flux and produces the EMF. Okay, this it is a cylindrical or drum-shaped structure, and it is usually built up of circular steel laminations. The laminations are used to reduce the eddy current loss. You know what is eddy current loss and what is the hysteresis loss. There are mainly two types of losses are there in magnetic structures: eddy current loss and hysteresis loss. We will study the losses separately. This is the armature winding. Okay, this is the armature core. In armature core, we are having slots. In slots, we are having the windings like this. Okay. Then the revolving armature conductors cut the flux and hence EMF is induced in the armature conductors. The conductors are kept in slots and insulated from each other. There are two types of armature windings are there. First one is verve winding and the second one is lap winding. Okay, we will say that what is verve winding and what is lap winding. That means the fashion of armature winding placed in this armature slots. Slots are there, no? Here in these slots we are placing the armature conductors. The fashion of that arrangement, that is mainly two types. One is called verve winding and the other is called lap winding. Next is the commutator. The main function of the commutator, that is EMF generated in the armature conductors are AC. See here, that is alternating. Here positive and here it is negative. Positive, negative. So this EMF induced or current flowing through here is AC in nature. The commutator that rectifies or that converts this AC into DC. See here DC current, that is only positive polarity. There will be no negative polarity. So commutator, function of the commutator that converts AC to DC. That is built up of copper segments of high conductivity. The commutator segments are insulated from each other by thin layers of mica. It is connected to the armature conductors. Next, brushes. Brushes, the function of the brushes are mainly made up of carbon. The function of the brushes is to collect the current from the commutator. Okay, then brushes are housed in brush holders. This is a brush. That means here this is a this black color is a carbon brush. Okay, carbon brush. That means the that brush connect this to load outer part. Then bearings are there. Bearings to used to reduce wear and tear. Next is a shaft. Shaft. See here. This is a shaft. Shaft is a mechanical connection towards the outer part. Shaft is used to transfer mechanical power from or to the machine. If the motor, mechanical power is the output, and if this is a generator, mechanical power is the input. The rotating parts like armature core, commutator, etc. are key to the shaft. The shaft is made up of mild steel with a maximum breaking strength. Next, air gap. Air gap is a small gap between armature, that is the rotating part, and field system, that is the stationary part. See here. See, there is a small gap, air gap is there. This is the field system and this is the armature. Okay, in between that a small gap is there. That gap is called air gap. Fluxes produced in the field system crosses the air gap and reaches the armature. When the armature rotates,